All right, for homework number 18, a lot of these problems are pretty similar until you get to the end. So you'll see lots of quadratics and finding maximums and things like that. So we're going to find two positive numbers that satisfy the given requirements. So the sum is S. Instead of a number, they're just telling us it's S. And the product is a maximum. So we have some sort of sum, like x plus y are going to be the two numbers. That's equal to S. And then the product that we want to maximize is, I'm just going to call it P equals x times y. So we want to maximize the product. So we're going to be taking the derivative of this equation, but I want to get it down to one variable. So I'm going to choose to solve for y. Now remember, S is a number. It's a constant. Normally they say two numbers sum to 20 or something like that. But this time we are just leaving it in terms of S. So now I will rewrite the product. So instead of x times y, it'll be x times S minus x. And because I want to take the derivative of this, I'm going to distribute the x through, because that will make the derivative easier to take. And then we want to take the derivative with respect to x of both sides. And remember, I'm writing this step out separately. You don't have to do that. But it's just a good reminder of what's happening from this step to this step. So P becomes dP dx. And then remember, S is a constant, so the derivative of S times x is S minus 2x. And we want to find the critical numbers for P. So the critical numbers would be when this dP dx equals 0. And if I solve that for x, I would subtract s and divide by -2. So that will be s divided by 2. And think about this. Anytime we have rectangle problems, like maximize a rectangular area, the largest area is always a square. So this makes sense that I would, this makes sense that, geez, this makes, okay, I don't know what's happening. Okay, so this makes sense that this would be x plus y equals s, and that, oh goodness, and that I would have to solve this and get half of the sum. Like if the sum is 20, the largest area is going to be when x and y are 10. All right, anyway, we should make this official by testing it on a number line. So I'm going to put s over 2 right here, and dp dx up here. And dP dx is just linear, right? It's a slope with a line of, it's a line with a slope of -2. I'm sorry, I can't talk today. So it looks something like that, which means dP dx is positive up here and negative down here. All right. That means that the product is increasing and then decreasing. So there's definitely a relative max right here. So the maximum product will occur when x is equal to basically half the sum, right? Yeah, and I'm sorry, I'm trying to decide if I need to justify. I don't think I justified on my actual answer key. But anyway, I would say because dP dx changes from plus to minus. I don't think I did that in these optimization problems because we usually don't have to, but it's a good habit to get into. Justifying just to justify. Okay, find the length and the width of a rectangle that has the given perimeter and maximum area. So this is what I was just talking about. This is really the same idea as this problem. It's just different context. So let's call our dimensions of our rectangle x and y. The perimeter equation would be 2x plus 2y equals 80. And the area that we're trying to maximize would just be area equals x times y. So we want to work on the perimeter equation. I'm going to divide by 2. Solve it for one of the variables. I tend to solve for y every time. And then sub that into the area equation so that it's all one variable. And that concept is not new. We do this with volume all the time. Like remember volume of a cone? We usually replace radius in terms of height or height in terms of radius so that the derivatives are easier to take. Same idea here. Okay, and if I want to find the maximum of something, then I'm going to take its derivative. Now, it's kind of funny. We're doing this in pre-calc right now without taking derivatives. We're just saying, oh, it's a parabola. I'm going to find its vertex. So you could do this without calculus for any of these problems where the function is a quadratic. But it's good practice to go through the steps so that if we're not given a quadratic, we can just continue to do our calculus steps and we'll get to an answer. Okay, so this derivative would be 40 minus 2x. The critical numbers come when we set 40 minus 2x equal to 0. And so if I subtract 40 and divide by negative 2, I get 20 for x. Plot that on a number line. And again, I don't really have to think too hard about this because dA dx is, again, something linear. And it's got a slope of negative 2. So it looks something like this, which means it's positive to the left of 20 and it's negative to the right. And that means that A increases and then decreases. So I would say the max area, they don't ask us what it is, just find the length and the width. Max area occurs when x equals 20, 20 meters. And y equals, let's see, so if x is 20, y is 40 minus 20, so y is also 20 meters. Remember, the largest area rectangle will always be a square, or as close to a square as you can get if you can't get one with fencing down the middle or whatever. So anyway, it's 20 by 20. And again, I could say because a prime or dA dx changes from positive to negative. For number 21, a farmer plans to fence a rectangular pasture adjacent to the river. The pasture must contain this many square meters. What dimensions will require the least amount of fencing if no fencing is needed along the river? So again, start with perimeter. This time it's 2y plus x should equal 245,000. And the area of this rectangle is still x times y. This one would be easier to solve for x, so I'm going to do that. So that x would be 245,000 minus 2y. So that just means that I'm going to have the area function in terms of y instead of x. So no big deal about that. So I'm subbing in x, or I'm subbing in 4x right here. I'm going to distribute. So area is equal to 245,000y minus 2y squared. And again, I can take the derivative with x of both sides. So I'm sorry, not the derivative of x, derivative with respect to y of both sides, because that's the variable here. So watch your notation there. So that's 245,000 minus 4y. And then solving for this, I'm using a calculator. I don't really want to crunch these numbers in my head. I guess we could if we were forced to, but let's see. 245,000 divided by 4 is 61,250. And I should have said something like this is when dA dy equals 0. Okay, so I got that. And then if I put this on a number line, 61 to 50, yet again, we have another linear because we keep getting quadratic, so derivatives are linear. It's got a negative slope, so positive, negative, increasing, decreasing. All right, so I know that y is 61,250. What is x? So let's calculate x right here. X is 200 and, let me split my screen so you can see both. 245,000 minus 2 times that number. Oh, insert multiplication. There we go. So 122,500. All right, so the question was what dimensions? So the max area will occur with x equal to 122,500, what is this, meters, and y equals 61,250 meters, and that's because dA dy changed positive to negative. Okay, so this one, bird's eye view of this picture looks like this. We have 400 feet of fencing. There's fencing down the middle, and they've got it labeled as X, X, and this is Y, so this is also Y, and so is that. What dimension should be used so that the enclosed area will be a maximum? So we want to, again, start with perimeter. So 4x plus 3y equals 400 feet of fencing. And the area of this corral, I'm assuming they're talking about the whole thing. I guess you could either do the area of one corral or you could do the area of the entire thing. I'm going to do the whole thing. 2x times y. Solve this for x or y. It doesn't matter. I'm going to solve for y. So same steps we've been doing. It's just a little uglier. This is like 400 minus 4x all over 3. You could split it up if you want to. The area then is equal to 2 times x times 400 minus 4x all over 3. Maybe I should split that up. So that's 800 thirds times x minus 8 thirds times x squared. I guess I should distribute that and split it up because remember I want to take derivatives. So dA dx, or a prime, is equal to 800 thirds minus 16 thirds x. And let's see, if we solve this, we get, for 0, we get 16 thirds x would have to equal 800 thirds. So if you multiply by 3 over 16, you get x is equal to something I should be able to do, but you can see that it is 6:51 a.m., so I'm going to let the calculator do it. So 50. And then what is y? So y is equal to 400 minus 4 times 50. That's 200. I can do that. Over 3. So y is equal to 200 over 3. And those are the dimensions, right? Because I guess I didn't do my number line thing, but when x is 50, dA dx is linear again. So see how we keep getting this? No one grades this number line, by the way. So if you don't draw it, it's kind of like, okay, but you should just to verify, or at least think about whether the derivative actually is changing from positive to negative. And I guess I'll say it in my justification. So the max area occurs when x equals 50 feet and y equals 200 over 3 feet, because a prime changes from positive to negative. Okay, this one, finally, we have a different shape here. So a Norman window is constructed by adjoining a semicircle on top of an ordinary rectangular window. So they gave us dimensions here. Find the dimensions of a Norman window of maximum area if the total perimeter is 16 feet. Now, perimeter does not include this line here. It's these 3 sides plus the outer portion of a semicircle. So let me remind you about circles. Circumference of a full circle is 2 pi r. Circumference of a half circle then is 2 pi r divided by 2. So in other words, it's pi r. So that's the circumference here. And then instead of r, we actually have pi times x over 2. That's the length of the radius of the circle. Okay, so our perimeter is supposed to be 16 feet. So we have 2y plus x plus, we just said the circumference of that outer half circle there will be pi over 2x. That's supposed to equal 16. And the area, what about area of a circle? Area of a circle is pi r squared. Area of a half circle is half of that, pi r squared over 2. And remember, instead of r, we have x over 2. So that's pi x squared over 4 over 2, so over 8. So the area is equal to, for the top portion, it's equal to pi x squared over 8 plus, don't forget, the area of the rectangle, x times y. And we don't want to have y in our area equation, so we're going to solve this equation for y. So 2y would equal 16 minus x minus pi over 2x. Divide everything by 2. 8 minus 1 half x minus pi over 4x. I could factor this out and distribute. I think I'll think about that later. This goes in for this y right here. So pi over 8x squared plus x times all of this. Okay, so area is pi over 8x squared plus 8x minus 1 half x squared minus pi over 4x squared. And again, I know I can combine terms. I guess I'll do these. It's just when you have pi's and non-pi's, it's like, is it going to be convenient for me to combine terms or factor out an x or an x squared? I don't think so. So pi over 8 minus pi over 4. 4 pi over 8 minus, pi over 8 minus 4 pi over, no, minus 2 pi over 8. Goodness. Good thing I set up my common denominator, right? Try this again. Pi over 8 minus pi over 4 is pi over 8 minus 2 pi over 8, which is negative pi over 8. Okay. Negative pi over 8, x squared, minus 1 half x squared, plus 8x. I think this is in a good spot to take the derivative. So if I find a prime, or dA dx, multiply this by 2, I get negative pi over 4 times x. Multiply this by 2, I get minus x plus 8. Solve for x. Okay, now I will factor out an x here so that I get negative pi over 4 minus 1. And I would set that equal to negative 8 on this side. Divide. And clean up. I don't like seeing this, so I'm going to say times 4, maybe times negative 4 over negative 4. So that's going to give me 32 over pi plus 4. That's x. And then what is y? You've got to go back and plug in for y. 8 minus half of this is 16 over pi plus 4 minus pi over 4 times this. So 32 over 4 is going to be pi over 8. Right? Yeah, times pi plus 4. And you could get a common denominator if you want to. It actually cleans up pretty nicely if you do that. Let me just do that just for fun. 8 gets multiplied by pi over 4. Minus 16 gets, oh wait, does 16 get multiplied by 8? Do I have an extra 8 down here somewhere? Oh, I definitely do. Sorry. Doop. Pi over 4 times 32 over pi over 4. Pi plus 4, the 8 goes up here. Sorry. The pi is up there. 8 pi. Okay, anyway, that makes things nicer. And then it's just minus 8 pi. And all of this is over pi plus 4. So y actually cleans up a lot. It's 32 over pi plus 4. All right, so, oh wait, why did I have a 32? That's a 16. Oh no, sorry. 8 pi plus 32 minus 16, I dropped that out, minus 8 pi. Okay. The 8 pi's cancel, and you get 32 minus 16 is 16 over pi over 4. Okay. Sorry, guys. Kind of a mess this morning. All right. So let's test on a number line just to be sure. If this is 32 over x plus 4, that was my critical number. And back here with a prime was linear, and when I factor out, I can see it had a negative slope. So positive to negative. So we do have that change. So the max area occurs when x equals 32 over pi plus 4 feet, question mark, yep, feet, and y equals 16 over pi plus 4 feet, because a prime changed from positive to negative. All right. Definitely the last problem was the most challenging. We have to remember things about circles and all this crazy work. But yeah, a good exercise and lots of algebra. All right, come see me if you have questions on this or anything else.